Greetings. Jim Hall's here. We're going to solve problem 4C in postlab 2. In the previous problem 4B, we'd solved for the radius of a proton, and that number came out to be 1.004 times 10 to the minus 13 centimeters. Problem 4C asks us to convert that to how many nanometers, right? Centimeters is a prefix that's 10 to the 2 meters, minus 2 meters, and nano means 10 to the minus 9 meters, right? So that's going to be where we're going. There are a lot of pathways to do this. The particular pathway I'm going to show you today is centimeters to meters to nanometers. In this pathway, we start with a prefix centi. We remove that by conversion to meters. Then we go and put the nano prefix back on the base unit meter, okay? So we're going to do that. We're going to take our number 1.004 times 10 to the minus 13 centimeters. We want to convert to meters, so we're going to use the conversion factor. 1 meter is 10 to the 2 centimeters. And what does that mean? It means because it's a centimeter, or 0.01, we need 100 of those centimeters to make 1 meter. You can always tell this is smaller than 1 because it's a minus exponent, right? This is also smaller than 1 because it's a minus exponent. So if we have a minus exponent, we're going to need a whole bunch of those to make 1. And in this case, it's 100. So now we've converted from centimeters to meters. The next step is to go from meters. So meters go on the bottom of the conversion factor to cancel out 1 meter. And then we're going to use the same principle. A nanometer is much smaller than a meter, so we need a whole bunch of them, or 10 to the 9th nanometers, to make 1 meter to use as a conversion factor. And now we've canceled meters out as well. And we're in our final answer, nanometers. When we put this in the calculator, I like to put 1.004 times 10 to the minus 13 into the calculator in parentheses. I do this anytime I have a exponential number. It just helps the calculator keep track. It helps me keep track of each part of the equation, right? So also with 10 to the 9, I'm going to put that in the parentheses when I put it in the calculator, and this as well. And if we get used to doing that, it just becomes a habit, and that habit will serve us well when we have long problems with multiple numbers using exponents. We put that in the calculator, and it comes out to be 1.004 times 10 to the minus 6 nanometers. Let's make that meter a little more legible, shall we? So 1.004 times 10 to the minus 6 nanometers. There are lots of other ways to do it. There are a lot of shortcuts. I don't prefer shortcuts when I'm solving chemistry problems, because when they get a lot longer, that's a lot of things to keep track of in my head and a lot of skip steps. And I like to myself, when I'm grading, to give points for each step, right, that I can follow. If I can't follow it, I don't know where I made a mistake. And remember, when you're solving problems, you're solving them for someone else, not for yourself. You know, but now you have to show someone else that you know. So take the time to do each step, and you'd be surprised how much farther you get in problem solving when you do one step at a time and try not to do it in your head. It's amazing. I know a lot of people love to do problems in their head, and I'm not discouraging you from doing that. I'm just saying when you're going to present it to someone else, you want to make sure they can follow what you're doing. So another thing that we need to always keep in mind is, does our answer make sense? Okay. And one of the ways we can tell and do a quick calculation is to use the exponential rules, which is if you divide by an exponent like 10 to the 2, you can take the exponent of the first number subtract the exponent, and that gives us minus 15 in this case. And then when you multiply exponents, you can add them. So we can take the minus 15 plus 9 and realize our exponent's going to be about minus 6. Now, it doesn't always work out to be exactly that because of multiplication factors and division factors, but reasonably, we can tell what the answer should be, and it should be around 10 to the minus 6, and that's the case in this. Thank you very much for your attention. Have a great day.